Monday's lesson is just like number patterns, because number patterns and the concepts and the methods around number patterns actually form the basis of graphs, or what we can call functions. So if you are new, don't stress too much. We're going to recap the sort of concept, and then we're going to get into the different types of variables we can work with in functions. And then we're going to start to look at different ways to represent these relationships. And this is now where we're going to start drawing graphs and understanding equations for graphs and so on. Okay, so let's have a look at this picture over here. We have got 3 different terms, and you can think of them as matchsticks, sticks, whatever you want, lines. But we can see that there are pictures that are created with these lines. So what I like to do the second I see a picture like this is I like to count how many things are making up my image. So if I go to image 1 and I count the sticks, or whatever we want to consider them as, and that was very poor English, I'm going to try that sentence again. If I count how many sticks are making up this image, I've got 1, 2, 3, 4, 5, 6, 7, 8. So those are like the little triangles around the edge. And then the square in the middle, 9, 10, 11, 12. So my first one, I have got 12 sticks making up the picture. In the second one, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And then we're going to do the last one. So 2, 4, 6. 26. I would appreciate if someone double checks my add in there. Let's just double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 18, 19, 20, 21, 22, 23, 24. Okay, I can count. Okay, so 26. Now, the reason I like to do this is because if you are someone who struggles a little bit with the visualization of how many things there are, we can now just write out what this number pattern is. So this is 12, 19, 26. And now we can ask ourselves, what is the pattern? So you guys can pop it in the chat. You guys can raise your hands if you want, but can anyone notice like a pattern that forms with the number of sticks I'm using to create my image? Right, Zintle, what do you think you see? Zintle?
Okay, remember that there's a pop-up on your screen. So you just need to click on that pop-up on your screen so you can communicate with us. Would you like to try that? There must be something on your screen that you need to click on so you can talk to us. Okay, while Zinhle is maybe figuring that out, we can just go to Alonde. Alonde, do you want to talk to us? Zinhle, we hope that you will succeed. If not, please do send me a message so I can help you privately.
Okay, Alonde, what do you think?
Can you hear me?
Yes.
I think in each will be, I think, 7.
Excellent, well done. So guys, what we see is that if we look at the numbers, or you can use the pictures, it really doesn't matter. But what we're doing to get from one image to the next is we're adding 7 sticks each time. Okay, so if I go to the image side of this, I've obviously taken this triangle from image 2 and I've pushed it to the end, which means I've added these bits in the middle here. And so there's 1, 2, 3, 4, 5. Oh, golly. 1, 2, 3, 4, 5, 6, 7 extra sticks that I'm adding onto my image. Okay, so as I add my sticks on, I'm actually adding 7 extra sticks or extra matchsticks or extra lines each time. Now, why that's super useful for us to know is because the next question is asking us how many sticks will there be in the 4th term. So if we carry on this pattern, I can already see lots of hands up. And Lovu, do you want to tell us how many sticks you think there will be in the fourth image or in the fourth term?
Guys, I think Zinhle succeeded, hey, Teacher Sam?
Oh, Zinhle, can you hear us?
Zinhle, you have to talk on your side because you are you are unmuted. Unmuted.
Technology today.
Yeah.
Okay, no problem. Let's see who else we have here. Oh, so many hands, guys. This is awesome. Lawrence, what do you think, or rather, how many sticks or lines or whatever are they going to be in term 4?
There'll be 33 sticks.
Excellent. And how did you get that? What operation did you do?
I added 7 plus 7
which
plus 7.
number?
I started from 26 and then I added 7. And then give
Excellent.
me
Well,
33.
excellent. Well done. Okay, so guys, we know that because the third image had 26 sticks and we're adding 7 each time, we would just add another 7 in order to get the fourth term. And so there will be 33 sticks in my fourth term. Now, I know some of you like to write them sticks or matchsticks or whatever in your answer. You can do that if you want, but honestly, 33 is fine. You don't need to write a whole long sentence for your answer. Okay, so this is sort of now where we're leading into eventually doing some graphs. The question or the question of writing down a rule for the pattern. Now, if you remember from number patterns, we were using TN and N or X and Y, and that's sort of where we're going with this. Now, when we write down a rule, basically what we want is something that looks like Y equals and then our X variable. Now, this Y, and we're going to chat about variables today, so don't stress too much. In this case, will be the number of matchsticks used to make the image. So if I want to find out how many matchsticks I'm using, what is the rule that I have? Now, this is why knowing what we're adding or subtracting or doing each time is quite useful to us. Okay, I can see some hands, so I'm going to ask. Sibonile, do you want to give us the rule? Do you have a question?
Yes, I do.
Okay, tell me.
How do you get how do you get 12 to 19?
Okay, so all I did there was I counted how many sticks were in each image. And so in the first one, I counted 12, and then in the second one, I counted 19.
Okay.
Okay, cool. Alrighty. Tando, do you have a rule for us?
Yes, ma'am, I do. And
Okay.
good evening.
Hello.
So it's Tn equals 7n plus 5.
Excellent. Well done. Okay, so guys, I just want to take a quick beat here and just explain what this all means. If you're writing your rule in terms of y, absolutely fine. You could write it as y equals 7x plus 5. So both of these are absolutely fine. Either one. Now, if we just draw a very, very rough table, I'm not doing this perfectly, so bear with me. And I don't actually like that. If I draw a very rough table where X is the term number, so is it image 1, is it image 2, is it image 3? And like I say, Y is the number of matchsticks. So if I go to term 1, I could substitute X in place of the X in my rule, and I can find out what Y is. So if I do that, I would have 7 times 1, which is 7, plus 5, which gives me 12. And we saw that in term 1, we had 12 matchsticks. If we then go to term 2, I could substitute in X for 2, so 7 times 2, which is 14, plus 5 gives me 19. I did have 19 matchsticks in my second term. And so what this rule does is it lets me find any term's number of matchsticks. So if I now say to you, how many matchsticks would there be in like the 700th image, you could just go and substitute in. So having this general rule is very useful to us because it allows us to continue to predict what the relationship is going to be. All right, so that is essentially the next question, which, oh no, hang on, we're going to come to that. There's a hand, so Sibonile, do you have a question? There should be a pop-up on your side to unmute. There we go.
How do you get, like, I don't understand the sum, the method.
To get the 7n plus 5.
Yes.
Okay, so there's a bunch of different ways that you can get it. I don't particularly want to talk about like a rule or anything. So what I'm going to do is I'm just going to scroll over for a second and I'm going to do this a bit neater for myself. You guys can hear a crying baby. I'm sorry. Obviously, one of my neighbors has a child who's not very happy. Okay, so if we draw a table and we have X and we've got Y, and then it was 1, 12, 2, 19, 3, 26. Okay. If I now want to figure out what am I doing to get from this number of X, so what am I doing to get from the X value to the Y value? I want to figure out what the rule is. And that's where this whole 7x plus 5 comes in. Now, we already established in this sort of writing out of my number pattern that I'm adding 7 each time. And so the clue, or sort of the way we can use the 7, is as the coefficient to the X. So if I start off with that and I say, okay, let's say I'm going to start with 7x. If we look at the very first term, that would be 7 times 1. Now that's 7. I want 12. So now I'm going to ask myself, all right, what should I add to 7 in order to get 12? Well, I know that if I add 5, I'm going to get 12. Now I want to check if the rule that I've got of 7 plus 5 works for all of my values. So let's check the second one. If I said 7 times 2 plus 5, I want to make sure I get 19. 7 plus 2 is 14, plus 5 gives me 19. So the rule's working. If I take it for 3, 7 times 3 plus 5, 7 times 3 is 21, plus 5 is 26. So what we do to find this rule is we first go and figure out what it is we're adding or subtracting each time. And if it's the same thing, then we are able to start working with our rule. And we start with that by saying, okay, whatever I'm adding or subtracting each time is going to be multiplied by X. And then I go and work further to say, all right, once I have that, what should I add or subtract to get this Y value that I'm wanting? Does that make a bit more sense, Ibonile?
Yes, ma'am.
Okay. With that being said, there are number pattern videos on Watobe's website. So if you go and have a watch of those, there's quite a few videos that explain this whole concept. Okay.
Yes, ma'am.
Okay. Guys, I went and checked that there were videos on Watobe's website. There definitely are videos from, I want to say early in the year, but there are definitely number pattern videos on Watobe's website because I wanted to make sure that this had been covered, and there are videos there. So please do go and have a look there if you are feeling a bit confused. All right. So the next question isn't like super important in terms of getting to grasp, but it is an important question leading up to what we're going to chat about today in terms of variables. So what we need to be able to do is we need to be able to work with both X's and Y's, or inputs and outputs, whatever it is that we are going to consider our variables as. So the question is asking which term or image number will have 110 matchsticks. So basically, if I took this pattern that I have here, and I'm just going to take all my scribbles off. If I took this pattern and I kept drawing, which one will I eventually have 110 matchsticks in? So which term number is that going to be? Now, if we go to our rule that we've just written down, we said that y was the number of matchsticks. And so now with this rule, I can use substitution. I know that my rule is y equals 7x plus 5. I know that y represents the number of matchsticks. And so I can substitute it in to solve for x. And we said x is the term that we're working with. And now this is just a basic solving of equations. All right. So we would subtract 5 on both sides. So this is 110 minus 5 equals 7x, which gives me 105 equals 7x. And then in order to get that x alone, we know that we have to divide both sides by 7, and 105 divided by 7 is 15. And so what this tells me is that the 15th image, whoops, let's fix that, will have 110 matchsticks. So if you drew this whole pattern out to the 15th picture, you would be drawing 115 matchsticks. All right, so I'm going to make this a tad smaller in case you want to screenshot everything all at the same time. Please do remember how to screenshot or to screenshot as we go along. I'll give you a second if you need to. Right, and guys, like I say, there are videos of number patterns on Watobe's website, so you can definitely go and catch up some things there. Lesejo, your equal signs can be underneath each other. It's not a huge stress, but obviously if your teacher has said they have to be underneath each other, then by all means write it underneath each other, but you don't need to. Okay. Guys, I'm just going to make like a comment here. If you're feeling confused, unfortunately, it doesn't really help me if we just say on the chat, no, this doesn't make sense. If you ask me questions, I'm happy to help. But like I said, like there are videos on this. If you are feeling confused, that's absolutely fine. But ask me so that I can help you. All right. Unfortunately, I can't do much with no questions. All right. Sibonile, do you still have a question or is your hand just up?
Oh, no, ma'am, I don't have a question.
Okay, no problem. All right, Lesejo, do you have a question?
Yes, ma'am. I want to ask, how did you get the 15, ma'am? Because you went by 105.
Okay, so, oh, sorry. No, I should have written my steps much neater. I do apologize. Let me fix that. So do you agree with me? Oops, sorry. Do you agree with me that if I move this down, so let's just, okay, it's fighting with me. From this step over here with the star, how do I get x alone? What do I need to do to get rid of that 7?
I think you need to divide.
Excellent. So what I'm going to do is I'm going to divide both sides by 7 in order to get x alone. And so when I go and divide 105 by 7, that's where I get 15 from. That's my fault. I should have written it like that. Thank you for pointing that out.
Yes, ma'am. Yes, ma'am.
Oops.
I feel like my people, maybe like, you know, I hope, because if no one is asking questions like Teacher Sam said, Teacher Sam won't be able to help you. Lungile, is that a question?
Yes, ma'am.
Yes, what's up?
Ma'am, I just wanted to ask that where do you get 110?
That was from the original question where it said which image will use 110 matchsticks. So I gave that to you in the question.
Okay, ma'am. Thank
Okay,
you.
so I would give you that value.
Okay, ma'am.
Cool. Right, Lumka, do you have a question? Okay, you need to unmute on your side. There should be a little pop-up.
Oh,
Here we go. What's your question?
for the triangles.
Okay, right now we're doing graphs. Pythagoras, for all of you that are asking, despite me having put it up at the beginning of the lesson, it will be in our next course. So in 2 weeks' time.
Yes, ma'am.
Okay. Nompumelelo, do you have a question?
Yes, ma'am.
Yes.
Ma'am, I just wanted to say I don't get anything that's happening here and
Okay,
how the equations are sitting.
Okay, so like I said, this has been done in number patterns. But essentially, as I explained earlier, what we need to do is we need to be able to sort of figure out what our number pattern is. So these are basically just the number of matches that we had from our pattern. And we needed to say, okay, well, if we were adding 7 each time, how can I use that to form a pattern? Right, but like I said, I would go and watch the videos on Watobe's website of number patterns and go and see how those rules come about. Okay.
Sorry, Teacher Sam. So my Pebs, just want to address this that you know, if you talk on the chart and it's not about math or about this question that we are busy with, and other people are asking also questions on the charts, I cannot see their questions because we are clouding the charts with everything else. So I might miss that person that is asking a question. So please, my Pebs, let's I know I love this class and it's respectful. So let's make sure that we are focusing on what Teacher Sam is saying. And if you do know and you do understand, it's okay. It's good for revision. It will ensure you that whenever this question comes in your exam, you'll get 100% out of this question. Okay.
Okay, guys, and yeah, to be perfectly frank, like we're here to do maths, as Yolanda says. And unfortunately, if you are not here to do that, I'm more than happy to remove students from this class, because unfortunately, all that's doing is creating distractions and creating an environment where people feel like they can't learn. And that's not the point of these lessons. So this chat is for questions. You're welcome to raise your hands for questions. And as I say, if you're not understanding something, just ask. I will happily explain it, or I will happily refer you to the website where you can go and get the videos or whatever the case is. But we're here to learn. And if we can't do that, then unfortunately, this isn't really going to work. Right. Bayanda, do you have a question?
Hi, ma'am.
Hi.
Yes, ma'am, when you were doing the set out, I kind of really didn't understand it.
Okay, when you say the set out, which part? Hang on, let me go back.
Like from I was understanding, do you know when you started counting the sticks,
Yeah.
that 33 came out, yes. But when you started bringing in the X and the Y and the 7,
Okay.
that has that thing, yeah.
Okay, so like I said, that's sort of like from number patterns. And like I say, if you go onto Watobe's website, there are number pattern videos there. I don't know what's happening. But essentially all we're trying to do is trying to find what the relationship is. If this point, if you are happy to know that you're adding 7 each time, that's okay. We're going to eventually start to talk more about how we get to these formulas. And that's what I'm saying to you guys, go and watch the videos, but we are going to talk more about this. So what I sort of need you to be able to see here is we're adding 7 each time, which is what we said.
Miss.
What did we say? Which is what we said over here. and then sort of understand that we can eventually use that to form a rule. Don't stress about getting the rule just yet. We're going to talk more and more about this.
Okay,
but
miss. Thank
just know
you.
that there are relationships. Cool. Right, again,
Oh,
guys,
Kazilani.
the 110 came from the question. Like, it wasn't something I just pulled out of a hat. It was in the question. That is why I used 110. All right. So 110 is saying that is how many matchsticks will be in the 15th image or the 15th term. Okay. And that is what we've written down over here, that the 15th term or the 15th image will have 110 matchsticks. Sandile, do you have a question for us? Sandile, there should be a pop-up where you can unmute yourself.
Ma'am.
Yes.
So I don't understand something here.
Yeah.
Like, as I said.
Oh, Sandile, try again. I don't know why you all of a sudden muted.
As I said that I'm new.
Okay.
So I don't understand.
Oh, why do you keep muting? This is weird.
Yeah, I think it might be just the network or something. It could be
yes,
the
ma'am.
network.
Maybe. I think so.
Okay, now I can hear you.
Okay, sorry. So I don't understand most of these questions.
Okay, so again, I would log onto Watobe's website and I would go and watch the number pattern videos, but we are going to talk a little bit more about the stuff that in terms of the rules and stuff as we go along in the section. So don't stress. Like I say, I just want you to understand that there is a relationship here.
Okay, ma'am.
Okay.
Thank you.
Sure. And for those of you asking for a brain break, unfortunately, if we don't get through what we need to get through, I can't give you breaks. So let's try and answer all the questions and let's try and make sure everyone's on the same page so that we can do that. Lumka, do you have a question? There should be a pop-up for you. There we go.
Can you put this down? Can you see?
Sorry?
They said the number pattern.
Yeah.
This that I can't understand.
Okay, so there's videos on the website that you can go and watch to hopefully understand. I think there were about 6 videos. So there's quite a few videos that you can go and watch to do number patterns. Okay.
Yes, ma'am.
Cool.
Thanks.
And my peps, as we do more questions, as we do more examples, you will see how nice and easy this whole thing is. Okay. I think you will learn by just doing.
Okay. Right. Here's your brain break. Whoops. Let's do that. For those of you that are new, just to explain what a brain break is. A brain break is basically just to take a little break from what we're doing. And it's like a little brain teaser that we do and we try and solve for. In this case, we've got some snails, we've got some beetles, and I think those are mosquitoes. So we try and find the value of these things in order to find the final values or the final equation's value. If you don't do it, that's okay. Give it a try. Otherwise, do make sure you get up, you stretch before we carry on. I'm not giving you a very long break, so I can see that there's already hands. I'm going to jump straight into the brain break, and hopefully we'll be able to carry on in the next minute or two. Okay, so Ntaba saying, do you want to give us a value anywhere here?
Hello, ma'am.
Hi.
Ma'am, I wanted to ask about what the videos of you
Say the
When I
last part.
when I try to link so that I watch the videos up now.
And Tabi saying, I can't quite hear you. Can you maybe just type it out in a message or on the chat, and then I'll try help you. I don't know, your sound's a bit funny.
Okay.
Okay, and then I'll help you. Alrighty. Bontle, do you have some values for us?
Hi, ma'am. The first one, 2 snails are 12.
Excellent. So what would that make one snail?
1 snail is 6, ma'am.
Perfect. I don't actually care about what one snail is because there's nowhere there where I have one snail, but just bear it in mind that that might be the case. And we can see that that will potentially be the case for our beetles. Okay, right. Let's see. Leobona, do you want to tell us the next one?
Ma'am,
Yes.
each beetle is 100. When they added together, it's 200.
Okay, so excuse me. Just double check. If we have 200 times 200, that gives me 4,000. So would you agree that the beetles, or 2 beetles rather, are actually 20, because 20 times 20 gives me 400, and then plus the 12 gives me 412. Do you agree?
Yes, ma'am.
Okay, good, well done. So guys, those beetles, and just going back to what Leobona said there, one of them would be half of that. So this one beetle at the bottom, as Leobona told us, is half. So that would be 10. The double beetles is 20. Okay. Nompumelelo, do you want to give us another one? Oh, sorry, everyone.
Hello, ma'am.
Hi.
So, ma'am, the mosquito is 16. So I'm gonna say 20 plus 20, which gives me 340 times 16. Sorry.
So, hang on, let me just get this right. Right. Okay. So 2 mosquitoes, you're saying, is 16.
Yes, ma'am.
Perfect. Because remember, guys, as Mpumelelo said, we have to do the multiplication first. So 20 times 16 is 320. And then when we add that extra 20, we get the 340 that we want. Good, well done.
Ma'am,
Yeah.
ma'am, can I also answer the last question?
Okay, sure, go for it.
Okay, ma'am, I'm gonna say 10 plus 16 times 12, which gives me 202.
Okay, now which operation should we do first? Should we do the multiplication first or the addition?
Multiple.
Good. So guys, we do the 16 times 12 first, which gives us 192. Then only do we do the addition, and exactly that gives us 202. Well done.
Thank you, ma'am.
Pleasure. Okay, so guys, those 2 mosquitoes were each equal to 16, which would mean that one is equal to 8, but we didn't really care about what one mosquito was worth. They were only ever 2, so that's all right. So like I say, give it a try. It's something to practice just like your basic order of operations, and just something to take a little break from what we're doing. Right. So if your hand was up to answer, you can put it down. We're going to carry on now with the lesson. If you still have a question, you can leave your hand up. Okay, Lumka, what's your question?
Ma'am, for the snails, I can't understand it.
Okay, so
it's 2 plus 1 plus 12, 36.
So for the snails, we're adding the same thing each time. So it's 3 of exactly the same values that I have to add each time. So if I ask myself, what is 36 divided by 3? That gives me 12. And so that tells me that if I add 3 12s, I'm going to get 36. And so that's why each of them is equal to 12. If I have 2 snails that represent 12, that means 1 snail is worth 6. And together they make 12.
Yes, ma'am. Thank you.
Good, well done. Okay, guys, so let's head on back here. And okay, I'm going to leave that out because we don't really have time to do that. Right, what I want to chat about today is different types of variables that we can work with when eventually going to work with graphs or being able to draw graphs. So we have what we call input and output values. Now, I'm just going to scroll down for a second. Some of you might have seen a flow diagram or a sort of spider diagram like this, where if we put certain numbers in and we perform operations on them, we get an answer. And that's sort of the basic thing of an input and an output value. So input values we generally represent with the variable x. That's a weird looking x. And essentially what will happen is we will perform operations on this input value to get an output. Now, when I say operations, I'm talking about addition, subtraction, multiplication, and division. Right, perform operations on input value to get the output. Now, this output that we're talking about relates to this variable over here, and this output is represented with a y. So the output is essentially the answer we get when performing the operations on the input. So if, and we're going to do that spider diagram in a second, if I tell you to take your input value and let's say times it by 2, once you've done that operation, the answer that you get is then your output. So what you put in versus what you put out. Now, these are 2 important variables to understand, and hopefully this rings a bell from what we just spoke about. Because when we start to talk about graphs, we talk about input values and output values, and then being able to plot their relationship to draw something visual to represent how they relate to each other. Okay, so let's have a very sort of general look at how input and output values work. So our first example here, we've got apples being sold at 16 Rand per kilogram. So let's just think about what that means. You can put your hand up or you can put it in the chat. How much would I pay if I bought 1 kilogram of apples? Like I said, you can put your hand up, you can put it in the chat. If apples are being sold at 16 Rand per kilogram, how much would I pay if I bought 1 kilogram? Okay. Bontle, what do you think?
Ma'am, you would pay 16 Rand.
Okay, while I've got you here, how much would I pay for 2 kilograms?
32 Rand, ma'am.
Excellent. And how did you work that out?
Ma'am, all I said is since you can buy 1 kilogram of apples for 16 Rand, I just said 16 Rand times 2. That would give me 32.
Excellent. Okay, so guys, these operations are what we're doing. So if we now consider, if we consider this relationship now, we've got an input and we've got an output. So our X is the number of kilograms I'm going to buy. And our Y, in this case, would be the price or the cost. And so what we've just said here is if I bought 1 kilograms, that would cost me 16 Rand. If I bought 2 kilograms, that would cost me 32 Rand because I would take 16 times 2. Who wants to tell me what I would pay if I took, or rather if I bought 3 kilograms of apples? Lumka, do you have a question or do you want to tell me how much you would pay?
No, ma'am.
Okay. Right, we've got some other hands. Let's see. Farid, how much am I going to pay for 3 kilograms?
Hello, ma'am.
Hi.
Ma'am, you're gonna pay 48 rand.
Excellent. So I'm going to pay 48 rand. Just because I saw, and I can't remember who wrote it on the chat, another way you could think about doing this is that you're just adding 16 rand each time. So to get 3 kilograms, you would say 16 plus 16 plus 16. That's absolutely
Yes,
fine.
ma'am.
Good. Alrighty. What happens if, let's say, I asked you how much it would cost for 5 kilograms now? Seho, how much would it cost me for 5 kilograms?
Hello, ma'am.
Hi, how are you?
I'm fine, thanks. And how are you? It will cost you 80.
Excellent. Well done. 80 rand. Okay, what happens if I asked you how much it costs for 10 kilograms of apples? Sandile, do you want to tell me? How much would 10 kilograms cost? Okay, Sandile, are you wanting to answer? There we go.
Ma'am.
Yes.
Oh yeah. I think it will cost about 160.
Excellent. 160 rand. Well done. Okay,
Yes,
so I've drawn a few too many blocks here. I don't think we need to carry on, but we get the picture. Well done, Sandile. Okay, so guys, this is now sort of where we're leading into this whole rule idea. We have seen that what I did is I took the X value, whoopsie daisies, the X value, and I times it by 16 rand each time. And that gave me my output. And so this is where we're going with these rules. I am seeing that if I know how many kilograms I buy, if I times that by the 16 rand, I know what my output is, or I know what my cost is. Okay, we're going to get to formalizing these rules, but this is what we need to start seeing. What or how do I get from an X value to a Y value? In this case, I'm taking each of my X's and I'm timesing it by 16 rand. All right. Bontle, do you still have a question?
Sorry, ma'am, I forgot to put my hand down.
No problem. Okay, guys, if your hands are up, I'm assuming you have a question. If you don't, you can lower your hand and we can move on. Right, Lumka, do you have a question?
Can you repeat again? I can't understand.
What would you like me to repeat?
The output.
Sorry, the
output.
Okay, so the output is what I do when I take my X values and I times it by the price. So in this case, I'm taking each of these X values at the top here and I times it by the 16 rand because each of these values represent how many kilograms of apples I'm buying. And so if I say I've got 1 kilogram, that's going to cost me 16 rand. 2 kilograms is 2 times 16, so 32 rand. 3 kilograms is 3 times 16, and so 48 rand. And so I've kept going.
Okay, thank you.
Okay, good. All right, guys. So this is sort of where we're heading in terms of actual graphs, understanding that there's an input and there's an output, and there is a rule that we follow to get each of these. So one of the ways that we can start to describe this is through a sort of flow diagram scenario. We don't use flow diagrams a lot, but it's quite helpful for us to understand as we get to this. So let's have a look. If each of these values down the left here are your inputs, so you're putting, think of this almost like a computer or like a machine. You're going to put each of those numbers in. Each of those numbers is going to be multiplied by 3, and then we're going to add to it, and we're going to get an answer. So let's follow our first, I don't know, spider leg. We're going to take an input of -3. We're going to put it into our machine. And the first thing we're going to do is we're going to times it by 3. So hands up or quickly in the chat, what is a -3 times a +3? Bontle, tell me.
Ma'am, it is -9.
Okay, while I've got you there, if I now go and say -9 plus 2, what do I get?
-7, ma'am.
Excellent. So by performing all of my operations, I get my output, which is my y. And so we did -3 times 3, and then we added 2 to that answer. So this is sort of the general idea. And from this, we can start to get sort of rules. So let's do 1. Oh gosh, sorry, everyone. I hope I'm saying your name correctly. Imitas, do you want to tell us what the output for 1 would be and how you got to that?
Ma'am, can you hear me?
Yes.
Okay. Is it 1, ma'am?
Yes, 1. Sorry.
So so you have 1.
Yeah.
You multiply by 3.
Good.
So
which gives you
1 times 3 equals 3 because there's only 1 3.
good.
So you plus 2.
Good.
That makes 5.
Excellent. Well done. So if we follow our branch, 1 times 3 gives us 3 plus 2 gives us 5. And so our output here is 5. Sorry, I wrote in a highlighter. It doesn't matter.